So today, another session, where the demo session where we'll try to understand. Hope you guys are from previous sessions. Let us try to understand what are all the different tools we have with us as a part of our curriculum, and what is the significance of this particular tool, and how they're, how what is the method that we'll be using to learn this particular tools, and then how we integrate them as a part of our DevOps cycle, and what are the different methods and different types of tool sets that we'll be using. So before going ahead with the regular sessions after the enrollment, so I just want to give you a brief about each and every tool that we have and what we'll be learning in this particular tools and how we are going to use it. Okay. So what are the different methods? What are different tool stack that we'll be installing, and what basic requirements that you should have from your end to work with this particular tools. Okay. So basically, to learn any kind of software tool, obviously you need to have a personal computer, laptop, or machine with a minimum basic configuration of at least a 2 GB or 4 GB of RAM, and a good processor, at least an i3 or i5 processor, which does not have anything to do with the tools, but it would be faster when you have at least a minimum basic configuration of the laptop. And if you have higher configuration, that is well and good. And most of the activities that will be performing both in Windows as well as Linux operating systems. Before giving ahead, why particularly we have to learn Linux and why it is important as a DevOps engineer that you should have a Linux knowledge is two important points. One is most of the environments in organizations and most of the applications are deployed into Linux operating systems. Okay. And which are very much secured when compared to Windows. And of course, if you are working on Windows applications and Microsoft projects, then you will be working with the Windows machines or Windows servers. The second important pointer of using Linux in official environments and is we cannot write any malware programs. Okay, we cannot write any malware programs for Linux distributions. Okay, so Linux, it is not a single operating system. It has various distributions. Various distributions are nothing but various types of operating systems. So before understanding its Linux history and other part, I'm just giving out the overview. And as organizations are using a lot of Linux operating systems, as a DevOps engineer, your day-to-day activities also would include working with these machines. And if you do not have enough knowledge, of course, Windows, everybody knows that as it is a graphical user interface. So what do you mean by GUI? That is graphical user interface, where you have physically, you could see with your eyes, and you can communicate with the machine. Like now I want to open up a new window or a new browser window. Simply I click on point and click, right? It will create a new window for me. So visually I'm able to see, and I'm trying to tell the browser that I want to open up a new window. But how do you do that with some almost not some almost most of the Linux operating systems that does not have GUI, where you cannot
Sir, here
have
we are able to
GUI.
see the only course curriculum. We are not able to
Yes,
see anything.
yes, I have not shared anything yet.
Okay, sir. Okay, sir.
Okay, so how does you communicate with something that does not have any graphical user interface like we see over here? Okay, visually, how do you communicate with it? That's where the CLI comes into picture. So what does CLI stands for? That is your command line interface. That is how you communicate with your machine, what you want to do, what executions, what is the task that you want to perform. Now imagine that if I want to create a folder, so basically what I do, I just 1 second. So I just right click over here. Okay. And then show more options. Right now it is modified. And then I create new, click on the folder name, and then a new folder will be created. This is completely graphical user interface that I'm working upon. But if you do not have this, you have a single window or you have a single application, that stands between you and the machine, that is your Linux machine. So how does you communicate, or how does you communicate or tell the Linux machine to do something? Okay, that's where your command line interface tools comes into picture. Okay, so we have various command line interface tools. Okay, and all are same. The functionality is same, but they go with different names. The inbuilt command line tool we have, especially in Windows, is your CMD, which is a command line tool that comes inbuilt with Microsoft operating systems. Along with it, you also have additional functionalities added, your PowerShell, right? Most of you might have heard about PowerShell and command line interfaces. Apart from it, what else we have? Okay, so whenever you try to connect to a Linux machine, okay, it will give you a shell executable application, which will be looking like this. I'm sorry for this errors. So this is how your command line interface looks like when you connect to a machine or a Linux operating system machine. And also the Linux operating system is open source developed by Linus Torvalds. And from there onwards, okay, people started as it is open source. Everybody can take the source code and they can modify as per their requirements, and then they can call it with a different name. That is the reason we have so many Linux distributions built on Linus Torvalds open source Linux. Okay, so the Red Hat guys, they have taken the open source, purchased the rights, and they have configured based on their requirements, and then they're releasing open hat, that is Red Hat Linux. Okay, similarly, the Ubuntu guys have taken the open source model, they have modified with their requirements, they have added new applications inside them, and they are calling Ubuntu. Similarly, Apple, Mac OS, where they have taken the open source of Linux, they have added their own advantages, tools that are their flagship products, and they are calling it as Mac OS. So if you see over here, the open source, the base is same. On top of that, you add up your layers or you add up your functionalities, and you can call up your own name, including your Android as well. Even the Android operating system runs on Linux model or Linux open source model. Even you, if you have enough knowledge of coding, you can take the open source Linux operating system entirely, add up your own configurations, tools, and other things, and you can compile the code and you can create your own operating system on your own. Okay, so this is little bit overview history. I'm not going much deeper. We'll do that in the regular sessions, but we need to understand the CLI tools. And usage of the CLI tools is same everywhere. Okay, usage of the CLI tools is same everywhere, where you tell the machine what you want to do it. Okay, you tell the machine what you want to do it. Simple as that. So that information that you are passing through the CLI will be passed on, okay, and will be sent to the machine, and it will try to execute the whatever commands that you have given to perform the functionalities. So basically, learning Linux is pretty much easier if you understand the concepts, okay, if you understand the commands, okay. Your day-to-day activities that you do in Windows machine all can be done in Linux also, but through a command. So here, as I've shown you, like creating a folder, I have to click on new folder and then a folder will be created. So in Linux, I have to use mkdir command, which will create me a directory. Okay. Similarly, to create a file, you create a file and name it. There in Linux, we use touch command. Okay, so for every functionality we do in Windows, parallelly and equally, we have a similar kind of functions in Linux as well, but with a difference called commands. So we'll be understanding the entire Linux architecture, what are all the various layers of architecture, how the commands are converted, which are passed from the shell through the kernel and from kernel to the hardware, and then how it converts back the message and how it displays you the output. All these layers will be understanding, will be learning, and then we'll also learn how to master or how to run Linux commands. The easiest method to remember all the commands and how you can perform day-to-day activities will be explained to you. So that's where our first, after getting introduced to DevOps, we'll be learning this particular part, that is our Linux commands and shell scripting. And also, people who initially, how I would be taking up is, initially The first few sessions I plan to take on AWS, making you sure to understand the first service, that is EC2, so that people who have difficulty in working with Linux operating systems, they can utilize the functionality of AWS and create Linux machines, and they can start working on it. And once we have done our part, okay, the next important thing will be looking is the source code management tools. Okay, so what are the different source code management tools we have? Basically, here we'll be working with Git. So this is your Git repository, my repository for one of the batches that are running right now. And we also will be creating a separate repository for our batch, okay, for our team. And whatever code that we'll be working upon, whatever Linux scripts or whatever, configurations that we do, everything will be updated in the repositories itself. And you will be added as a contributor whenever there are assignments. You can directly log in into the GitHub account, and whatever permissions that I've given it to you, that will be, we can work upon the repositories as well. So this is how your GitHub looks like. So we have to create an account using an email in the GitHub account to maintain our repositories. Okay. So the same what you are seeing right now over here also will be present in real time also, but it's a different licensed version. But the UI, the graphical user interface, will be same. Okay, and from here you have to download to your local repositories using the Git commands, where we'll be learning the entire from the basic level to the mid level we'll be learning, and then we'll be working upon. And also in your local machine, you will be installing GitHub Git Bash, which is this particular tool which I'm showing it right now over here. This is basically a Git Bash, which is command line interface tool that comes whenever you install Git onto your local machine. Okay, so this is how you run your commands, or everything will be learning up. Do not worry. So by default, you will not find this in Windows. You have to install Git, download it, and as soon as you install Git, automatically the Git Bash also comes into automatically, it comes as a package, and you can start using it as a CLI tool as well. Okay, why I prefer Git Bash as a best CLI tool is we have certain limitations. If you are running in CMD, we have certain limitations. Certain Linux commands cannot be executed in command prompt, inbuilt command prompt, and also PowerShell. But Git comes with some of the Bash and shell executables, where we can execute most of the Linux commands directly in Git Bash. That is one advantage that I would suggest. Apart from it, if you're comfortable working with any of the CLI tools like command prompt, PowerShell, or whatever tools you're comfortable, you can use it. Okay, but the execution will be same. Next, we'll be learning a Maven. Okay, so what exactly a Maven is, and what is the purpose of okay, so Maven, another important tool that we'll be installing, and we'll be working with Maven. Maven, as I said in demonstration as well, demo session as well, it is the builder tool that is used to create packages for Java applications. Okay, it is the build tool that is used to create the packages for the Java applications. And most important part is, before going to Maven, we have to have a Java installed in our machines with properly environment variables set, because Maven runs only if you have Java installed on your machine. Even for that, I have a JDK which is available to me in the repositories itself, which I'll be giving you the links. You can download, because earlier it was a free download, but right now the Open JDKs have Oracle have made them that you have to create an account to download anything, the Java JDKs. So I have my own version of JDK that I'll be giving you the link. First, we have to install Java, then only you'll be able to run the Maven. Okay, not only Maven, Jenkins, Tomcat, all this depends on Java environment platform. So we have to install Java. Both we'll be seeing how to install Java on both Windows as well as Linux, because we'll be working in Linux environment mode. Next, coming to Maven, we'll be understanding what are the different phases or different Maven life cycles. If you just Google it, you'll get it. Maven is a standalone, you know, one second. So if you see over here, we have so many, stages of Maven lifecycle itself. Okay, where it starts with your compilation, validation. It starts with validation, compilation, and then test a package where we package artifacts are generated. Integration tests are performed, verification is done, and then install if you want to install it locally onto your machine. And then if you do not want to install directly, you want to deploy into any application servers like Tomcat, JBoss, or any other application servers, web application servers, you can deploy. This forms the life cycle of Maven. So whenever you sit for interviews, one of the basic questions they ask, if they ask you, do you have experience working with Maven? Can you explain us what are Maven goals or what are Maven life cycle? So this is what the Maven lifecycle is all about, and we have to give information about each and every phase. Okay, so then only they'll be understandable that, of course, you have worked with Maven exclusively. And the most important point over here that we have to understand working with Maven is the pom.xml file. It is the heart of Maven. Without that, there will be no any execution. Let's say if I mean, right now with the compilation phase directly, if I say package, what it will do is it will try to validate, compile, test, and then comes for the package. Let me show you that simple command. Simply, I would say MVN package, and then it says a build failure. Okay, the reason is the important piece of configuration that Maven requires, okay, is your pom.xml file. Okay, this is the pom.xml file which is missing. That is the reason your Maven cannot execute, or it cannot make any package out of it. So what exactly this pom.xml file stands for? Okay, so this is important file where we have to write various configurations inside this pom.xml file. Okay, and what exactly it consists of is depends upon how we are configuring the project. Okay, and the POM itself stands for project object model. Okay, project object model. So this have a certain configurations that are required to build your Maven packages. We'll also learning how to write the pom.xml file on our own if we do not want. And also, what is the easiest methods to automatically create pom.xml file based on your project configuration. So these are all the basic things that we must know before going to advanced sections of deployment using Maven. So we'll do that as well. And next comes the important part, the deployment using Maven manually, how we deploy into Tomcat server. And coming to Tomcat, it is one of the web application server. We'll be seeing what are the different configurations that are required to run a Tomcat server. One important mandatory thing is Java. Java has to be present to run Tomcat compulsorily. And these are all we'll be learning first manually. Okay, step by step. Directly, I cannot directly take you into a specific project and show you that this is how everything is done if you don't understand the basic steps. So first, we'll be learning all these steps manually one by one. Okay, the baby steps we take, we understand the basics, then we understand the mid-level configurations, and then finally the advanced stuff. So once the Tomcat execution is done manually, next comes the CI/CD part. Okay, which is as a part of CI/CD, we'll be learning Jenkins as our important tool. Okay, so what exactly Jenkins work? Okay, how Jenkins work? What are the important steps that you need to take care to install to run a Jenkins server on your local machine? And if you're running it in a cloud or a remote server, what are the important steps that you need to follow? So what I meant to say over here is each and every tool, we will see a different concepts. I mean, different things in a particular tool. The first one important is installations and configurations on various operating systems. Okay, we have to know this. Otherwise, we cannot directly learn the theoretical part of a specific tool and run it. What if you get lost or you get struck with a specific execution and you don't know what is wrong with this if you haven't installed or configured anything about that particular application? Either it may be Git, it may be Maven, it may be Tomcat, it may be Jenkins. So each and every tool, we will be seeing the first important part is installations and configurations on various operating systems and what are the prerequisites environments that we need. Second important thing is the functionalities of this particular tools will be seeing in depth from basic level to advanced level. And finally, how it is done on a project level, the advanced concepts for each and every tool will be covering all these things, all these three parts. And coming to Maven, it's basically I'm not trying to scare you or something, but it is the easiest tool that you can work with. And if you don't understand about this particular tool, it is the scariest tool that you should be stay away from working with. Okay, so the reason is that if you understand the basics of installations, configurations, and how other tools are being integrated into Jenkins like Git, GitHub, Maven, Tomcat, Docker, Kubernetes, Ansible, how these are being integrated, how Jenkins server is communicating with these other tools. Okay. So if you understand the behind the scenes, how the communication happens, how the configuration works, what is the mechanism that is happening. If you understand that, it is easiest tool to learn quickly. But if you skip those things and think that, okay, I may not be performing any Jenkins administration day-to-day activities in my organization, I don't want to look out to all this, then you are mistaken. Even if you're not a Jenkins admin server, but still you have to see the Jenkins administration and you have to be aware as a DevOps engineer. That will help you out in a lot of ways. Okay. What are those things? I'll be explaining you and we'll be seeing real-time issues that we can face with Jenkins and how it works likewise. So how once the Jenkins is installed locally on your machine, that looks like this. Okay. So this is the Jenkins dashboard for previous batches which we're executing. And these are all the jobs that we are writing and the CI jobs, and each and every jobs looks like this. And there, what is the configuration, how you are building it, and everything will be, you can see over here. It's a basic one. Okay. The local free so open source Jenkins server that I'm running over here. So similarly, we'll be installing in your machines as well, and we'll be learning each and every part of this and how you create, pipelines or how you create jobs. Okay, pipeline jobs like you can see freestyle job. We have Maven project. We have pipeline job, multi-configuration project, multi-branch pipeline, and organization folder. How you can handle the organization's entire various projects in Jenkins. Everything will be learning from the basic level to the advanced level. Okay. And next comes after the CI/CD part. Yeah. And also you'll be introduced to automation over here. As I said, these all parts in Maven, Tomcat, and Git will be learning manually step by step. And automation is the important criteria as a DevOps engineer we should pose, and automation gets introduced from this part. Okay. As soon as a developers push a new code, okay, into their server or sorry, into the repository, all the way how it picks up Maven, how it compiles the package, and how it deploys to Tomcat server or any cloud EC2 instance. Everything will be configured automatically, and you just have to be looking and monitoring of the pipeline. Everything goes seamlessly. Okay, they can directly test the application whether it has deployed or not. So this kind of automation and what are the different types of build triggers. Okay, so this terminology might be new to you, or we'll be learning that as well. What is the terminology? What is this vote stand? What is the trigger? What is the build trigger? And everything will be giving from the basic level to the advanced level. Okay. And after Jenkins comes your SonarQube and Nexus. Okay. So basically, these two tools are a code quality analysis tools, and Nexus is again artifact repository tool. These two are different, but code quality analysis tool is very much important to integrate with your CI/CD. Is why? Because developers are will be writing a lot of code, right? So everybody are humans and everybody can make mistakes. Okay, we are not machines not to make mistakes, right? So obviously we make some mistakes. Similarly, if any kind such kind of mistakes are done, okay, your code quality analysis tool, that is SonarQube, will identify that for you, and it will give you various matrices like what is the code smells, okay, what are the duplicate code that you have integrated, you have how many number of lines that you have copied and pasted, and is there are any dependencies related to any malwares or code leaks, code coverage, how much code you have covered so far. So these results will help the developers to maintain a clean and neat code in the organizations. But you may ask me, when this is related to developers, what it is to do with the DevOps engineers. Okay. So at the end of the day, of course, it is related. The results will be helpful for the developers. But the catch over here is this tool can break the pipeline, or it can stop the pipeline whenever there is certain quality gate. Okay. We maintain quality gates and quality profiles. And if I say, if the quality of the code is 80% and more, then only you run this pipeline and build the package and deploy it. If it is less than 80% of the quality, then do not run it. Okay. So that makes a clean code, and also that will make help the developers to maintain neat and clean code. And this why this is the reason, as a DevOps engineers, we should integrate that with our pipelines to make sure the quality of the code is maintained, and the results will help the developers to write a neat and clean code. Next, the artifact repositories. So that is Nexus. Why particularly Nexus is one of the popular tool which has a large community base, and why it is important is the purpose of this particular tool is we are using the developers are writing code and we are running multiple times the pipelines, and also we are generating a lot of artifacts. Artifacts are nothing but packages. Okay, so we have to have something to store these artifacts. I'll give you a simple example why we need this storage of artifacts. Now imagine, right now my current application version is 1.2.0, okay, or 1.2.3. It is working fine. Now we have added new features, and a new version of package has been deployed, that is 1.2 or 2.0.0. This is the newer version, and it has been deployed. Once it has been deployed, there is a issue with the application. Application is not working as intended. Okay, what is my immediate step? What will be my reaction? So first, instead of looking why this particular application is not running, as an engineer, what I should be, the remedy that I should be doing is roll back to the previous version. Okay, which means roll back to the previous version, that is 1.2.0 first, so that the end customers, they will be still working, or they'll be using the previous version without any hesitation, because it was working fine. Now, after rolling back my failed application to the previous working condition, now I can start digging deeper why this particular new deployment has been failed. If I didn't have a package of previous version, imagine my situation. I should do something to fix the current version and then make sure it is running. Okay, so it may be time killing, as well as you're losing your customers who are using the application. And imagine if this is a banking application, what could be the result, and how many frustrated customers would be there, and how much the banks will lose the customers. So the main functionality of this artifact repository is to maintain different versions of packages. That is one reason whenever there is a failover, you can simply roll back, and then use it, the previous version, so that the end customers will be working. Still, they don't see any new features. That's fine, but still the application is working. They're working fine. Later, dig deep down and work with the newer version, and test it again this time, and try to deploy it and maintain the versions. And that is the reason the package management and artifact management is most important, and Nexus is used to configure and versioning of our artifacts is done with the usage of Nexus. And again, this also will be integrated with the Jenkins, and we'll see how it works as soon as Jenkins executes. And before deploying to the environment. We'll try to, the package will be, updated or pushed to Nexus repository, and then it will go for the deployment so that we have version of it. Next, we have monitoring tools. Okay. So, which is the monitoring of Prometheus, one of the important tools, Prometheus and Grafana, which are used, okay, for monitoring all these tools that we are working right now, all the environment servers that we have over there where the application is being deployed. So this monitoring, why it is important is, as they're running continuously, the applications are running continuously. It might be sometimes there might be a memory issue, sometimes there might be a network issue, sometimes it might be a power failure issue. So if you do not monitor them, okay, you do not know what is wrong with the environment servers. Okay, we're talking about servers and applications, both as well. So keeping a track of everything is good thing, right? So you keep a track of everything so that everything is monitored and there is no any downtime. The entire things that we do as a part of DevOps and cloud engineers is to make sure there is no downtime of the application. Either it may be e-commerce application, it may be a banking domain, or it may be a retail application, or it may be healthcare application, whatever project that we are working. The whole agenda of entire process is to make sure that application is running on fine and customers are not facing any issues. Okay, the main agenda of everything in a software company, of a service based company, is to make sure the services that we are providing are 100%. There is no any 0.0.0 downtime of maintaining the application if it is a maintenance project. Okay, next comes the important tools, that is your Docker and Kubernetes. One of the important part of DevOps again is microservices. So what exactly these tools do, how they help individual DevOps engineers, and how they work with DevOps ecosystem is, earlier days we used to have a monolithic applications. Okay, so what I mean monolithic applications is that the entire application is packaged into front-end, back-end, database architecture, 3-tier architecture, 2-tier architecture. Likewise, we have so many architectures, and it is completely bundled into a single structure, and it is being hosted on a server. Now, if the server goes down, all the components are gone. Likewise, we have to have a fine solution, and then that's where the containerization or microservices architecture came into picture, where breaking down the entire structure into individual units, okay, into individual units, and then working so that if any of the component individually is lost, okay, the other components are not affected, okay, so that you can only concentrate on the lost component and you can start working and redeploying it rather than looking at everything. So that is the concept of microservices and use of Docker with microservices, and creating a real-time project, and also integrating that with Kubernetes. So in Docker, the main thing that we'll be learning is containers. Okay, container is nothing but an individual unit of execution that contains libraries and binaries. Okay, so before understanding containers, we'll be seeing what is virtualization, and then we'll be going to containerization. So what exactly virtualization is? Virtualization is nothing but creating a virtual server on a physical server. Okay, we'll be seeing that first, what exactly virtualization is, and then we'll be learning the concepts, and we'll see more hands-on what is the difference between a virtual server and a container, how they work, and what are the benefits and everything we'll see. And to orchestrate or to maintain these containers, Docker has an inbuilt service called Docker Swarm, but it does not support any rollbacking strategies or other important advanced functionalities. That is the reason out of Docker, after learning Docker, we'll be learning Kubernetes, which have all the advanced functionalities when compared to Docker with respect to deployment. Okay, so again, like Jenkins, Kubernetes is the important tool. Same, like if you understand what are the concept, if you understand what is the backend mechanism, how it works, and what are its components, then it is the easiest tool to learn. And if you don't understand any of the concept, and you will not be able to understand forever. Okay. And also, learning Kubernetes is the easiest part, and setting up the Kubernetes cluster is the toughest part, because we have so many components uh, are there. But do not worry, we'll be learning each and every component. We'll be seeing how it is easier, rather than manually installing each and every component. How we can write a shell script or a script that will do everything on behalf of us. Okay, how we can do that, we'll be learning. Next is your configuration management and tool, which is Ansible. So, what is the purpose of Ansible? The main purpose of Ansible is configuration management and patch management. So, what do I mean by configuration management and patch management? So, imagine this: I'm running with 100 servers. Sorry, I'm running 10 servers in my data center. Now, there is a requirement. I need to have a specific version of Java installed on all these 10 servers. Okay. I have my systems engineer. I'll raise a ticket to him that I want this to be done on these 10 servers on this particular time frame. I need all the 10 servers to be installed with a specific version of Java. Now imagine you have 100 servers. If you raise a ticket to your systems admin or system sysadmin, of course, manually 100 servers is possible, but it is a lot time consuming. Okay. What if I have a solution where, with execution of one particular script, or we call playbooks, I can install a specific version of Java on all 100 machines with a single execution within fraction of minutes. So imagine that doing it manually on each and every server, logging into it, and even that is possible to run certain we can share scripts. That is also possible, but that is time consuming. But the second solution is, within fraction of minutes I'll be able to install a specific version of Java on all the 100 servers. And also we could also think the other way, that I want to remove something, or I want to remove a specific set of data files or logs, or I want to remove certain applications on versions on all the servers. Yes, we could use Ansible. And also I want to upgrade or update a specific service on all the servers, 100 servers. Yes, that is possible. So it has a lot of functionalities that can be used for patch management and configuration management. Okay. So we'll be having in-depth sessions about Ansible, how you can set up your Ansible, and how you can work with Ansible, and how you can deploy something into the agent nodes. And before understanding Ansible, we'll be seeing a little bit history about Chef as well, because Chef was the previous successor of Ansible, and Chef was the most popular tool earlier. And later, when Ansible got introduced, everybody started using Ansible. So we'll see a little bit history and what is the difference between these tools and what is their architecture. Okay, why they are called with different architectures, because it is important interview concept or a question that you might come across, like what is the difference between Chef and Ansible. And so you have to give them an answer or explanation, like what is the configuration of Chef, and what is the configuration of Ansible, what is their architecture, why Ansible is called agentless, and why Chef is called agent architecture. So we'll be seeing this. So that is the reason I'm stressing out. Every tool we'll be seeing with installations and configurations, and then we'll be understanding the functions of it, comparing with other versions of previous other tools, how they were doing. Later, we'll see the advanced functionalities of each and every tool. Finally, we have the ticketing tool. We'll be seeing what exactly, how in an organization, how you get your work. Okay. How your work is distributed among DevOps engineers, not only DevOps engineers, in general, how work is distributed to employees. How do you know daily activities, what to perform, what are your things once you log in into your organization, or once you go to office, what are the things. So everything will be planned inside your sprint cycles or sprint planning. Your scrum masters will be there, along with stakeholders, deliverable stakeholders. They'll be having the discussion, what is the progress of the project, and then they'll be discussing in the sprint planning, like what are the plans we have for the coming up days. Like there are some organizations will have sprint cycle for 7 days, some will have 15 days, some will have 30. Likewise, we'll be having and in real time how you are supposed to work. Everything will be learning under this particular sessions like Jira. Okay, so what will be discussed? How tasks are segregated to, say, example, a DevOps team has 5 people, okay, 5 DevOps engineers. How the tasks will be distributed to each and everyone, and how much story points that you have to give for each and every story. What are the deliverables, and what is the acceptance criteria that you should be doing to a specific story or a specific task. Everything will be discussed in these sessions. And this is an overall project management tool that most of the organizations are using nowadays. But some organizations, they have different tools like BMC Remedy, ServiceNow, and also Jira. Likewise we have. But if you understand the one functionality of one particular tool in one organization, it's only a little bit slight difference in another organization. That's it. Next comes the important is your cloud. Okay, so what exactly a cloud? I will be learning. We have already seen everything, the basics, just an overview of cloud and how it is done. But in the sessions, we'll be going in depth, understanding each and every concept of cloud itself. Okay, how you can create a free tier account, and once you have created, this is the basic, login page. Once you have logged in into your AWS account, like what are the, this is EC2 landing page, and if you go to home page, what are all the different services that we'll be learning as a part of our program. Everything will be giving up, and we'll be seeing from the ground level. And even if you are pretty much new, do not worry. And again, it is the easiest one. Even here in AWS also, you have CLI. Do not think that every time you'll be working on the console. No, that is not right. You have CLI also for AWS, which we need to run AWS commands. One second, guys. Yeah, sorry. Uh, where was I? Even AWS also have a CLI which will be used to communicate with the AWS console. That also will be learning. And even in organizations, official documentation is allowed to refer if you're stuck somewhere, if you're not familiar with AWS CLI. So do not get afraid that again CLI we have to remember a lot of commands. Okay, so the command syntax will be pretty much simple. That is AWS service name and what you want to do with the service. Simple as that. Okay. Now, in console, if I'm trying to create an EC2 mission, that is a virtual mission, I go to EC2 and then click on launch instance, then configure, take whatever configurations that I want to take, like what would be the RAM size, what is the operating system, and then I click on create. So it will create a virtual server. Similarly, in command line, you have to use the same pattern. Instead of GUI, you will have CLI, where you have to give an instruction in the command format like AWS EC2 create. What is the name of it? What is the operating system of it? What is the size of it? Simple as that. So again, why I'm particularly stressing out is each and every tool in AWS, sorry, in DevOps and AWS that we are trying to learn are the easiest tools, very easiest tools. You just have to have a basic knowledge how a computer works. Okay, what is hardware, what is operating system, what is keyboard and mouse. If you understand this basic knowledge, then you are eligible to learn the entire DevOps topics, DevOps tools and AWS with ease. But again, the catch is you have to understand the architectures of the tools, the frameworks of the tools. What is the installations and configurations which are different from operating system to operating system, and what is its functionalities. The functionalities lies same in each and every operating system. Only the methods of installing the application differs. Okay, in Linux and Windows machines, but the functionality is same everywhere. So from Tuesday, I think we'll be having the regular sessions, understanding in AWS, we'll be learning again, sorry. In AWS, we'll be learning VPCs, what are the networks, storage services, file services, and then compute services, And then you can see over here, we have included AWS CLI, which can be used to run CLI command, that is command line interface. And then finally, we stop at Terraform. So when we are learning AWS, what is the purpose of learning Terraform? What is the use? Okay. Nowadays, as all the organizations have moved to cloud, reusability of the code has been a major problem. Okay, what is the purpose of reusability of the code? So in AWS also, we have infrastructure as code service called CloudFormation. Okay, even that will be learning. So these are used to create multiple resources with a script, with a JSON format script. Okay, and today one customer has come and I want to create an infrastructure for this customer, and I've written a JSON format CloudFormation template and I've executed it. Okay, after a few days, I got another customer on board, and this time I want to create a different services with 30 to 40% of similar infrastructure for the from the previous customer. So for me, again, I have to take the previous customers. I have to make so many configurations. I have to duplicate it. I have to make so many configurations and add new customer configurations of services to that CloudFormation template, and then deploy it. So of course, the advanced functionality is there, but still reusability is pretty much limited when compared to the Terraform. So Terraform gives you that ability for maintaining a larger resource codes, as well as writing multiple configurations for various customers and maintaining a proper module structure, the reusability of the modules, how you are reusing again and again, so that makes life easier, and you have much more control when compared to CloudFormation. So, and it is becoming one of the popular tool for cloud infrastructure engineering teams or cloud platform teams. And also it supports multiple service providers, not only AWS, it supports other tens of cloud service providers like Azure, GCP, Alibaba Cloud, Oracle Cloud, Kubernetes. Likewise, we have so many cloud service providers that are there out there. Along with it, you get a lot of additional advanced functionalities which are limited while working with CloudFormation template. Okay, and all this will be learning by implementing a real-time projects that even you get hands-on by accessing the code repositories which is available in our code repositories. Okay, so yeah, that's it, guys. That's it. The brief about the training curriculum program that we have. So kicking off from Tuesday, we'll be having regular sessions which we start with understanding the DevOps and start learning Linux, and we start with Linux. So even if you have not enrolled yet, please contact to the management. They'll help you with the uh, making you how the enrollment works. So I'll stop the session one by one. You can ask me questions.
Sir, what are the major challenges we face in the DevOps in context of new technology involved, or the some certificates, or the I heard these terms but I don't know, means what are the major challenges are faced in the this career in DevOps.
So I understood only one part. Other part was completely I was not aware of what you're asking me. Can you speak a little bit louder? So what are the challenges?
We face in this DevOps career.
Okay,
No,
in the career or while learning DevOps?
no, not learning in the career.
In the career, see, the only part is your experience matters, and the experience has to speak. And if you're not proficient, or if you're not efficient in handling these all tools or tool stacks that you have available in your organization, then every day it's a challenge. The only thing is your practical knowledge that you implement over there. And most of the time, almost 80% of the time, you'll be hired by an organization where there are already DevOps engineering team, and only they'll hire you. Unless and until you're lucky enough where you end up in a product based startup, okay, to get higher packages. So obviously you'll have your teams. There will be somebody to give you a proper KT of the entire project, and you should be aware of the entire life cycle of the project. And then from there onwards, there will be a minor challenges of faced, like most of the time it would be pipeline failures or deployment failures. Apart from it, technically, Nothing much. If you are experienced enough and you have seen a lot of stuff and understood the tool cycle and your project life cycle pretty much clear, nothing else can be a challenging part. But to be honest, again, yes, there are new challenges that you may see every time. Okay, if you don't know the tool properly, especially if you're working in Kubernetes, Prometheus and Grafana, ELK stack, these are complex tool structures that we have out there. And if you don't understand their pattern, even if you miss in one place, you will never understand anytime at all. So you should be careful while taking up the KT. Make sure you get 100 out of 100 knowledge on the tools itself before going into getting into the project. So that will save you.
Hello, sir.
Yes.
Hello. Naveen here, sir.
Yes.
Sir, like I'm asking about like as a real time, sir, as a DevOps engineer only can configure all the tools or some other team or I'm saying about as a DevOps engineer only we can able to install and configuring the all tools or a specific team are there, sir, for installing and configuring these all tools, sir, while we using the project, sir.
Yeah, that's what I mentioned very clearly while explaining to you. I think you missed that part.
Yeah, sir.
Every organization already have a DevOps team. So that is the reason somebody has left or they have required more manpower, they're hiring you. So
Okay.
all the tools are already present. Already
Okay.
they're using it. So what
Okay.
will you go there and what will you install newly? Nothing is there to install. Unless and
Okay.
until there is no
Okay.
DevOps in the organization. They hired you as an experienced DevOps engineer, like a startup or a mid-level company. They hired you as a new DevOps engineer. You are the person responsible to set up the entire DevOps. Then
Okay.
you have to discuss the tools that you want to use. Then you have to discuss the limitations. Then you have to discuss about you know platform dependencies, and then get the approvals, and then test it on various test environments, and then set up, install, and configure and set up the entire thing. If
Okay.
nothing is there, but 90% every time, everything is already there. You will be
Okay.
added as a new user and you start using it as a user. And
Okay.
don't expect that they'll give you administration privileges in
Okay.
every organization. No, not at
Okay.
all.
Fine. Got it. Yeah.
Sir,
Yes,
hello.
Satya.
Yeah,
Yes.
yeah. Sir, I want to ask one question related to Sonar Cube. So when we configure the Sonar Cube pipeline, does we need to train that Sonar Cube about our coding standards, or the Sonar Cube will automatically check all those things, depend upon the programming languages and everything, or how it work?
So, how could I give you this example? Have you heard about the vending machines anytime? I mean,
Yes,
in the
yes,
airports, something
yes,
like
yes.
that.
Yeah, yeah. When we put money, if we
Yeah,
want to.
obviously, sometimes based on the product, you insert 50, sometimes 100, sometimes 200, and how it identifies and gives you the product. Similarly, the inbuilt functionality of SonarCube is aware of all the programming languages and their frameworks and their classes and everything. So you once the code is given it to it, it will automatically analyze. There is only certain dependencies that we have to give, particularly what required for us and what matrices we need. For that, we need to make some configurations.
Okay, so that we will do, or a project manager, or any other concerned person will do that things, or
See, basically, it's a joke actually. Don't take it seriously. The project managers are there only to harass you to do some work. Okay, they will not do anything. Okay, I'm
okay.
just telling it in a joking. Do not take it personally.
Understood.
So
So,
they'll not do it. If they are doing it, why will they hire you? If they everything they are able to do it, why you are present in the organization or why any DevOps engineer is present in the organization?
yeah,
They
but
have their own set of day-to-day activities. As a project managers, they have to look out for everything that is whether it is going smoothly or not. Apart from it, they do not interfere into your day-to-day tasks unless and until somebody from your team has that experience and he has recently become a project manager. And if any of the resource is finding difficulty to resolve any task, then he may step in and he may guide you. This is how it can be done. Apart from it, they'll not be handling all this stuff.
okay. So I think that
So for organizations, you'll be noted once you get into hired into a team, you'll be notified if something goes wrong. Who is the POC? Whom should you contact? Everything will be given to you.
Okay, okay. So Sonar Cube will handle almost 99% of the things, right?
Yes.
Okay, thank you. Okay, that's only from. And also one more thing. So but that Git Bash and AWS CLI is totally different. So can we
Yes.
use the AWS commands in Git Bash?
Yes, we could use for that. We need to configure AWS SDK into our Git bash, and then we have to give the
Oh,
authentication, and we can run AWS commands as well. Let me show you. I think
oh, okay, okay,
I've
okay.
already configured for the previous batch.
Okay,
You can see, yes, AWS commands even from here. I can start running it.
okay. So that all we will learn.
Yes, yes, I'll be showing you how you need to configure and
Yeah.
how you need to authenticate with your keys, and then how you can communicate with console from the Git bash itself.
Okay, that is great, great. Okay, sir. Okay, that only from my side.
Uh, Hello, sir.
Yes, sir, Sagar.
Yes, can I speak in Hindi so that I can explain my question clearly? Can I?
Sure, but stop calling me sir. You can call me Raju. Okay.
राजू, ओके ओके। सो मैं जानना चाहता हूँ कि डेवॉप्स की मेजर जो तीन ड्यूटीज होती हैं वो एग्जैक्टली क्या है, जितना मुझे आइडिया है, करेक्ट मी इफ आई एम रॉन्ग, कि बिल्ड, डिप्लॉय एंड रोल बैक एंड मॉनिटरिंग, ये तीन एक्टिविटीज मेजरली होती हैं। इज इट ट्रू? मतलब
Yes.
डेली हम जो एक्टिविटीज होती हैं
100%.
ये तीन।
Yeah, go ahead. Go ahead.
यस
Complete.
यस 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 सर, इतना ही था सर क्वेश्चन।
So वो 100% चाहिए. We as a DevOps engineers are acting bridges between the development teams and operation teams, and we make sure build and deployment has happened in a smoother manner. And then if there are any hiccups in the deployment, make sure that it is rolled back to previous version, and then establish a proper platform for monitoring, and then collaborate with teams to intimate them. So these are all the major day-to-day activities that we are supposed to do as a DevOps engineers. But if there are any other activities that you have to perform, then it purely depends upon the project that you are working and the organization that you are hired. Okay, it depends from company to company.
Okay. So as you said that we have a limited jobs for this already, means not the startup. I'm not talking about the startup, but majorly all the organization has this DevOps team. So I think there are limited jobs for this DevOps. So how we can
No, I
get?
never said that. I never said that.
Mm.
So what I meant was there are a lot of opportunities right now out there for DevOps engineers. Okay. Uh, when you compare it with the other technologies, DevOps right now is standing at fourth position of the requirement. Okay, the first being the machine learning, second being the first being the artificial intelligence, second being the machine learning, third being the cloud, and fourth being the DevOps engineers itself. Okay, if you just Google it and you'll find it out. We have lot of opportunities because every time organizations are bringing onboarding new projects, and every like if they have 10 projects, only 5 DevOps engineers will not be able to do it. So organizations require at least hire a team, DevOps engineer team specifically for each and every project so that they can have much control on it. So you have a lot of opportunities, and it all depends on how you are marketing your profile, and how you are getting the calls scheduled, and how you're following it up with the HRs to schedule the interviews. It all depends on it. And there are hundreds of remote works that we have right now. If you can search for any remote job sites, you can see how much requirement is there for remote DevOps engineers as well. So there are a lot of opportunities.
Okay, okay, sir.
So any other questions, guys?
Sir, one more question. What is the course price and what is the duration?
The duration is approximately, it goes for 2.5 months, give or take another 10 days, based on holidays and my availability sometimes. Okay. But otherwise, it would be 2.5 months. Price, you can contact the management team and they'll help you out with price and the enrollment part process and other stuff.
Okay. Sir, are you working in the current any organization, or you are the full-time trainer? Please brief yourself.
Uh, Yes, I'm a completely full-time trainer right now. I'm not working in anywhere. I was working. So in IBM, I worked for 8 years, and my previous organization was Wipro, and I worked there over there. And from past 1.5 year, I'm an individual contributor. I'm working as a freelance trainer, and I have my own set of projects that I'm supporting as a third-party vendor to some of the organizations from US and Europe countries.
Thank you, sir.
Okay, guys. Yeah, if no any other questions, Kalyanji, we can wind up the session. Thank you, guys. Thank you so much for joining.
Thank you. Thank you.
Okay, sir. Thank you. Thank you very much.